showing your units is going to be very, very important here, because the units in a concentration calculation, mass is measured in grams and volume is measured in liters. So the trick here is, if I don't want you to make a liter of solution, if I only want you to make 100 milliliters or 50 milliliters or something, you're going to have to take that milliliter amount and convert it to liters, because the formula here requires that mass be measured in grams and the final volume of solution be measured in liters. But you probably will not ever make a liter of something. So let's say the example is I want to make a solution where my overall final volume is 50 milliliters. Okay? This solution here, if I say that something has a concentration of, let's say, 30, actually let's go with, concentration is equal to 20 grams per liter. Anytime you see grams per liter, it's concentration. This implies that if I actually make this solution here, okay, it's going to look like this. I'm going to have a big beaker, okay, and my 1 liter mark is up here. And before I put the water in there to do the dissolving, I'm going to put 20 grams of powder, and then I'm going to raise the volume. I'm going to add water until I hit my 1 liter mark, so that my final volume is 1 liter for this whole mixture. Okay, I'm going to stir it. It's going to dissolve, whatever. But here's the deal. I can make this exact concentration using a much smaller volume. Okay? How would I do that? What's that mathematical word that I'm looking for when I want something to be exactly the same concentration but a smaller amount? This is to this as that is to that. So we're basically making a ratio here. Okay? We're making ratios. If I tell you, I don't want you to make a liter of that. I don't want you to measure 20 grams and put it in a liter when all you need is 50. Okay, that's a colossal waste of material. Waste. We want to try and be as efficient as possible. So, if I say that I only want 50 milliliters, well, am I going to need 20 grams of stuff for 50 milliliters? No, I need 20 grams in 1 liter. But right now I'm trying to compare 50 milliliters and 1 liter. It's like comparing apples and oranges. It's not the same thing. So we have to convert from milliliters up to liters. We start off with what we've got and we say, okay, well, I have 50 milliliters and I want to bring it up to liters. How many milliliters, because I got to get rid of this unit here, so I'm going to have to put it on the bottom. How many milliliters are there in 1 liter? 1,000 milliliters in 1 liter. Well. This cancels out with this. I'm left with the unit that I'm looking for. Okay? I multiply whatever's on the top, divide it by whatever's on the bottom. So here, showing your work involves dividing 50 by 1,000. What does that give you? This ends up being 0.05 liters. All right? Which means that I can make this exact concentration of a solution, okay, where I had the 1 liter here. Now I'm going to have a much smaller bucket. Okay, my 50 milliliters is right here. I can figure out, if I know my volume and I know the concentration I want, then I need to figure out what my mass is going to be. I just have to rearrange this 3-variable equation. Okay? So if I do that, if I'm told that I've got a concentration of 20 grams per liter, I've just figured out that my volume that I'm looking for is 0.05 liters. I don't know what my mass is. Well, I can rearrange an equation to solve to isolate the m. If C is equal to m over V, how do I get the m alone? What do I have to do there? No, let's do letters first. You multiply both sides by V. And that gets rid of the V over here. Okay, it gets rid of the V here so that your m is all alone. All right, you have a habit of running into this and just throwing the numbers in right away. Make sure you know what it is you're looking for. Because as you move on into science, your formulas get bigger. You get more variables than 3. 3 variables is as easy as it gets. It's going to get harder, and you've got to be good at rearranging these formulas. Okay? So the formula for m is C multiplied by V. Okay? Do we have our C? Do we have our V? Well, we can solve this. Now you put your numbers in. So now we've got 20 grams per liter, right? And that's actually like writing it this way, grams per liter times 0.05 liters. Shocker. Look at that. The L's cancel out because they're on top and they're on the bottom, and we're left with the unit we're looking for. So that's why I really want you to learn how to rearrange these equations and put your units in, because your units are a good proof that you've done the equation properly. If you're left with the G, which is grams, well, that's the unit for mass. That means you've done it properly. Okay? So, if we work this out, can somebody figure this out? All right. This ends up being 1 gram. Now, that means that if I go back to my little container here, instead of 20 grams of solute, if I put down 1 little gram of solute here, okay, I measure that on my mass, and then I add the solvent in there until I get my 50 milliliters, I've made the exact same concentration as the big guy. It's exactly the same. Okay? This is how concentration works. For concentration calculations, you do need to know how to do this. Right? The next thing you need to know is how to make a concentrated solution. And we'll go over that in another video. Another way of looking at this is comparing the different ratios here. Okay, we've got our concentration for both of them, but 1 gram over 0.05 liters is equal to 20 grams over 1 liter. They're the exact same. If you divided this by this and that by that, you'd get exactly the same number for the concentration. They're just smaller amounts of the same mixture. It's like once this big one was made, I just went in and measured out 50 milliliters out of that liter. And if I evaporated that water, I would have been left with 1 gram of solute if it was properly mixed. Okay, that's all this means. Now,